In this video, we'll be solving a related rates problem. We're asked to find the rate of change of the distance between the origin and a moving point on the graph of y equals sine x, if dx dt is equal to 2 centimeters per second. So we want to find the rate of change of distance, so we can call that dd, dt. That's what we're looking for. And we're given that dx dt is equal to 2 centimeters per second. But I can't put that number in until I've differentiated my function. So I need to find my function. Since we're looking for the rate of change of distance, I'm going to need the distance from the origin here, and this point has coordinates 0, 0, to some other point along this curve. Let's just put it right here, and it'll have coordinates x, and then sine x is the y coordinate. So I need to use my distance formula. If I have 2 points, x1, y1, and x2, y2, the distance is the square root of x2 minus x1, quantity squared, plus y2 minus y1, quantity squared. That's a subscript, not an exponent. And to make my differentiation easier, I'm going to square both sides of this. Let me put my points in though. I have d equals the square root of, and then x minus 0, quantity squared, and then my y's are sine x minus 0, quantity squared. So if I square both sides, that'll give me my function to work with. I have d squared is equal to x squared plus sine squared x. Right. Now when we look for a rate of change, we're going to differentiate implicitly with respect to t. So I do the derivative of every term and then multiply for the chain rule. So the derivative of d squared is 2d, and then multiply that by dd dt. The derivative of x squared is 2x, and multiply that by dx dt. And then this last term is a composite function, so I have something squared, so the derivative of that is 2 times that something to the first power times the derivative of that something, which is sine x. So the derivative of sine x is cosine x. So my inside function on this was sine x. My outside function is u squared. I think I'm going to divide everything by 2 here to simplify a little bit. So these will cancel, and these will cancel, and these will cancel. Let's divide by 2d so that I have just dd dt. Alright, the x I don't know, but dx dt I know is 2. So I have x times 2 plus, and then sine x times cosine x. And in the bottom I have a d. Simplifying, I'm going to need to sub in d in here in the denominator and then turn these around. So the rate of change of distance is equal to 2x plus sine x cosine x over, and then I'm going to put in square root of x squared plus sine squared x.